Assalamualaikum and hello. My name is Muhammad Razmi Arizwan bin Muhammad Rosli. In this video, I will explain about DC motor feedback analysis, SFG, block diagram and transfer function. In this part, we will look at question 2a. The question asks whether the expression yt over ut, which is given as a polynomial in time, is a transfer function or not. To answer this question correctly, we need to recall the definition of a transfer function and identify whether the expression is in a correct domain. This type of question commonly appears in final examination and usually tests student understanding of basic control system concept. Before solving this question, it is important to we understand the basic concept of transfer function. A transfer function is defined as ratio of the Laplace transform of the output to the Laplace transform of the input, assuming zero initial conditions. Mathematically, it is written as Gs equal Ys over Us, where both Ys and Us are expressed in Laplace domain. A transfer function are always represented in the S domain and not in the time domain. Therefore, any expression written in terms of time, such as Yt or Ut, must be converted using the Laplace transform before it can be considered a transfer function. To determine whether the given expression is a transfer function, first we must refer the definition of transfer function. A transfer function is defined as ratio of the Laplace transform of the output to the Laplace transform of the input, expressed in the S domain as Gs equal Ys over Us. In this question, the given expression is Yt over Ut, which is written in the time domain and contains a polynomial of time. Since the expression is not represented in Laplace domain and does not involve Ys over Us, it does not satisfy to the definition of transfer function. Therefore, the given expression is not a transfer function. Now, let's move to the question B. This question requires us to analyze a DC motor feedback control system. The given diagram shows the electrical and mechanical component of the motor, including amplifier, armature circuit, torque constant, back electromotive force, and mechanical load. The objective of this question is to derive overall transfer function of system based on the given parameters. This type of question commonly asked in control system examination and usually carry higher mark because it tests student understanding of control system and block diagram analysis. For question B2, we are required to draw the overall block diagram of DC motor control system shown in question 2b. Starting from the input voltage, the signal pass through the RC network followed by amplifier. The amplified signal then drive the DC motor, which consists of the electrical and mechanical subsystem. Finally, a feedback path formed from to the output back to the input, completing the closed loop system. For question B3, we are required to identify the main components of the DC motor control system shown in figure question 2b. The system consists of electrical component, mechanical component, and a feedback element. Each of these components plays an important role in determining the dynamic behavior of the overall system. For question B4, we are required to find the overall transfer function by using the block reduction method. First, we combine all the blocks in the forward path of system. The forward path consists of the RC network, the amplifier, the electrical of the DC motor, and the mechanical load, including the integrator. By multiplying the transfer function of this cascaded block, the forward path transfer function is obtained. Next, the feedback loop with gain K is considered. Using the standard closed loop transfer function formula, the overall transfer function of the system is derived. For question B5, we are required to verify the overall transfer function obtained earlier using the Mason-Gain formula. First, the signal flow graph of the system is drawn based on the block diagram. Next, the forward pass gain is identified, followed by the feedback loop gain. Since there is the only one forward pass and one feedback loop, Mason-Gain formula can be applied directly to obtain the overall transfer function. The result obtained using Mason-Gain's formula is the same as the one obtained using block reduction method. Thus verify the answer. As a quick check of understanding, consider this short multiply choice question. Which of the following correctly define a transfer function? The correct answer is C, because a transfer function is defined as the ratio of the Laplace transform of the output to the input with zero initial condition. To conclude this video, we have successfully answered all part of the question related by DC motor feedback control system. We begin by analyzing whether a given expression a valid transfer function based on its definition in the Laplace domain. Next, the DC motor feedback system was represented using an overall block diagram. The main system component was identified, and the overall transfer function was obtained using block reduction method. The result was then verified by using the Mason-Gain formula to ensure the correctness of the solution. Thank you for watching. I hope this presentation will help you in understanding DC motor modeling and control system analysis. Bye.